Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 8. This is Section 8.4. The name of this lesson is Scientific Notation. And our central question may not match what we're going to have. So we'll just move on here. So, this whole chapter is about exponents. So we did Sections 1 through 3. We did properties of exponents. Today we're doing scientific notation, which uses properties of exponents, and then we'll be covering exponential growth and decay in 8.5 and 8.6. So, and scientific notation is very useful for science. Well, it's got the word science in it. It's basically a way to use significant digits or significant figures to basically deal with really big or really small numbers. Okay, so because sometimes if you have, if you're talking about molecules like a mole, a mole is Avogadro's number is 6.23 times 10 to the 23rd, molecules per mole, something like that. It's just really hard to deal with numbers with a ton of zeros after them, or a ton of decimals, like a decimal with a lot of zeros too. Okay, so this is kind of a way to deal with numbers in a more precise way that makes it easier to work with, I guess. So. Okay, so what's the definition of scientific notation? Well, a number in scientific notation has the form c times 10 to the nth power. Okay, c times 10 to the nth power, where c needs to be between 1 and 10. It can be equal to 1, but it can't be equal to 10. Okay, so it needs to be a number between 1 and 10. It can be equal to 1 if it needs to, but it cannot be equal to 10. And the other thing that needs to be true is that n is an integer. Now, what's an integer? You guys remember what an integer is? Integers are positive and negative whole numbers. Okay? All right, so it says deciding if a number is in scientific notation. It says is 76.34 times 10 to the 8th in scientific notation? Explain your decision. Well, it kind of looks like something in that form. We got, a number times 10 to something. But there is something wrong with this problem here. Look at the first number. Is this number between 1 and 10 right here, or no? It is not. So the answer is no, because 76.34 is not between 1 and 10. So it's kind of in scientific notation, but not really, because the first number is not between 1 and 10. That's very important. So, all right, and here's some general rules for scientific notation. You want to think of scientific notation like a scale or a balance, okay? So if you basically, what you do to one side is going to affect the other side, and you need to balance it out so if you do something to one side, you need to kind of do the opposite on the other side to make it balanced, okay? So if you make one side bigger, the other side must become smaller, okay? And conversely, opposite is also true. If you make one side smaller, the other side must become bigger. Okay? And these are all kind of just words right now to make more sense when we go through some actual problems. But this is kind of a little bit different. If you're multiplying by a big number, it will make the decimal number bigger. And if you're multiplying by a small number, it will make the decimal number smaller. And the last thing we need to know is that when we're moving a decimal to the right makes the number bigger, and moving it left makes it smaller. Okay, so we'll talk about this more when we get closer to that. Okay. All right. So it says changing a number from scientific form to decimal form. It says multiplying. So we have 2.356 times 10 to the 5th. It says multiplying by a big number makes it bigger. Well, that's right. 10 to the 5th power, we're multiplying by 100,000 basically, right? We're multiplying by 100,000. So if we multiply 2.356 times 100,000, which is a big number, is that going to get bigger or smaller than 2.356? Well, it's going to get bigger. So let's write 2.356. So if we're multiplying by a big number, to make the number bigger, which way are we going to move the decimal to make it bigger? Well, if I move it to the left, now I have 0.2356, which is getting smaller, so we're not going to do that. Actually, you won't be able to see this, but we're multiplying by a big number, so to make the number bigger, we're going to move it to the right. So right now, we're at 23.56. Now we're at 235.6, okay? Wherever the loop ends is where the new decimal is going to be, okay? So we moved it twice, but we're multiplying by 10 to the 5th, so we're going to move it 5 times. We moved it 1, 2, 3, 4, 5. So the new decimal is right here, and wherever there's an empty loop, we're going to put zeros. Okay? So our new number, and I'm going to rewrite it, 235,600. And the way you put your commas is you work your way 3 back from the end. So the decimal's right here, so we're going to have 235,600. And that makes sense, right? If we multiply 2.356 times 100,000, it's going to get bigger, okay? All right, next one we have, it says multiplying 7.59 by a small number makes it smaller. So we're multiplying 7.59 times 10 to the negative 4th. Well, we're multiplying 10 to the negative 4th. Remember, 10 to the negative 4th, put that over 1, it's a negative exponent. It's going to go down here, which equals 1 over 10 to the 4th. And 10 to the 4th is 1 over 1, 2, 3, 4. 1 over 10,000. So we're multiplying by 1 10,000th. All right, so we're multiplying by a negative exponent is going to make it smaller. So let's go ahead and do this here. So I'm going to put 7.59 right here. So we're multiplying by 10 to the negative 4. So we're going to move the decimal. If we're making it smaller, we're going to move it to the left 4 times. So we're going to go 1, 2, 3, 4. Here's our new decimal. Plug in zeros where the loops are. So our answer is going to be 0.000759. Okay, so we multiplied 7.59 by a pretty small number, so it's going to make it smaller. And likewise, at the top, we multiply 2.356 by a big number to 100,000, which is going to make it bigger. All right, let's go the opposite direction now. It says changing a number from decimal form to scientific form. So it says if we make the original number smaller, this is the balance part I was talking about, the 10 number must get bigger. Okay, so we're going to move the decimal until the first number is between 1 and 10, because that's very important. But we need to make sure that we multiply by the correct 10 to the right power, okay? So I'm going to move the decimal. So where's the decimal right now in this 359 million? Well, it's right at the end behind the last 0, right? So we're going to move the decimal until it's between 1 and 10, okay? You try at home, try to tell me when to stop. So I'm going to move the decimal until it's between 1 and 10. So now we're at 359,000. Now we're at 35,900. Now we're at 3,590. Where do I stop? Here? Or here? Or here? We're actually going to stop right there. We're going to stop at 3.59. Okay, so if we stopped one before, that'd be 35.9. We don't want 35.9 because that's not between 1 and 10. So we have 3.59 times, okay, 10. Now, how many times did we move the decimal? Looks like 1, 2, 3, 4, 5, 6, 7, 8. We moved it 8 times, but we had 359 million, and we ended up with 3.59. Is to go from 359 million to 3.59, do we make it smaller or bigger? We made it a lot smaller, right? So what that happens is the balance part is if we made this first number smaller, other number needs to get bigger. So I'm going to put 10 to the positive 8 to keep it balanced, okay? I'm going to put 10 to the positive 8 to keep it balanced. If you make the big number small, the 10 number needs to get bigger, and vice versa. If you make the first number bigger, the 10 number needs to get smaller, okay? So down here, the same thing. If we make the original number bigger, the 10 number must get smaller. Okay, so let's go ahead and try this one on our own here, or not together here, actually. Okay, so we have 0.00098. I need to move it so it's between 1 and 10. So I need to move the decimal so it's between the two numbers that make it between 1 and 10. So I'm going to keep going here. So tell me when to stop. That's 0.98. That's 9.8. Is 9.8 between 1 and 10? It is. 9.8 is between 1 and 10. But from 0.00098 to 9.8, do we make that number bigger or smaller? To go from 0.00098 to 9.8, we made that first number, this number is bigger, so we need to make the second number smaller, which is going to be 10 to the negative what? How many times do we move the decimal? 1, 2, 3, 4. 10 to the negative 4 is going to be our answer here. Okay? So that is how you do convert something from decimal form to scientific notation. It's kind of like a balance thing here, okay? All right. So this is kind of the opposite direction. Okay, we have a few examples. Try to do, we'll zoom out a little bit here. Try to do checkpoints 1 and 2 and 1 and 2. See how you do. All right, welcome back. So we'll go back to red because that's what we were doing for the first ones here. So it says rewrite in decimal form. We have it in scientific notation. We're writing it in decimal form. So we have 5.56 times 10 to the 7th. Are we multiplying 5.56 times a big number or a small number? We're multiplying it by a big number. 10 to the 7th is a big number. It's 1 with 7 zeros. So we're going to write 5.56, and we're going to move the decimal. So if we're making it bigger, because we're multiplying by a big number, are we going to move the decimal to the right or to the left? We're going to move it to the right. To the right is going to make it bigger. So I'm going to go 7 times to the right. 1, 2, 3, 4, 5, 6, 7. Fill in some loops here with zeros. So 55, 600, oops. So this is going to be every three digits we're going to put a comma. So we have 55,600,000 is going to be our final answer. Does that make sense? Yeah, we multiplied 5.56 times 1 with 7 zeros, which is going to make it a really big number. So hopefully, if you got that, good job. If you didn't, keep following along and we'll be good to go. All right, we have 7.125 times 10 to the negative third. Are we multiplying by a big number or a small number? We're multiplying by a small number. 10 to the negative third is a small number. So I'm going to do 7.125. So I'm going to move the decimal to the left to make it smaller. So I'm going to go 3 times to the left. 1, 2, 3. There's our new decimal. Here's our zeros. So we have 0.007125. And that's going to be our answer. All right. Now let's go ahead and go into rewrite in scientific notation form. Here we go. All right, so we have 0.000000832. All right, first things first. Is this in scientific? Is this is the first number? Sorry, is this number between 1 and 10 right now or no? It is not. It's not between 1 and 10. So we need to move it so that the first number is between 1 and 10. So I'm going to move the decimal. I'm going to move it to the right to get to those other numbers. So we're going to go 1, 2, 3. Do I stop here? Well, that's 0.832. That's not between 1 and 10. What about this? That is between 1 and 10. That's 0.832 times 10. Now, this is the balance part here. We made the original number a lot bigger to get to 8.32, which means we need to make the second number smaller. Moved it 1, 2, 3, 4, 5. So it should be times 10 to the negative 5th. And that should be our answer. All right, last example. We have 184,900. All right, where's the decimal right now? There's no decimal. It's at the very end. Okay, now we got to I got to move the decimal so that it's between 1 and 10. So let's move the decimal. Here we go. 1, 2, that's 1,849. That's not quite right. That's 184.9. That's not right. That's 18.49. That's close, but it's not between 1 and 10. We're going to stop right here. 1.849 times 10. Now, we made the original number a lot smaller to get to 1.849. So we're going to move the decimal. We moved it 1, 2, 3, 4 times 10 to the positive 5 is going to be our answer here. All right. So the first number is between 1 and 10, and we made the first number smaller, which means the second number, the tens number, needs to get bigger. Okay. Moving on. Multiplying and dividing scientific notation without a calculator. It's actually, we are going to use a calculator. We don't need to worry about that, and they spelled notation wrong too, which is not good. Okay, so this is going to be using properties of exponents a little bit. So the trick to this, we have 1.4 times 10 to the third and 7.8 times 10 to the fourth. We are going to multiply like parts. We're going to multiply like parts. So I'm going to multiply the first two decimals together, 1.4 times 7.8. And I'm going to multiply 10 to the third times 10 to the fourth. Okay? And then if we multiply those together, 1.4 times 7.8 is 10.92. Now what's the 10 digit going to be? Well, we have 10 to the third times 10 to the fourth. We're multiplying with the same base. What are we going to do to the exponents? We're going to add them, subtract them, multiply them. We are going to add them. 3 plus 4 is 7. We're going to get 10.92 times 10 to the 7th. All right. Okay, is this in scientific notation right now? It looks like it is, but it's not quite because 10.92 is not between 1 and 10, so we need to fix that. So I'm going to rewrite the problem down here, 10.92 times 10 to the 7th. Okay, which way do I need to move the decimal to make it between 1 and 10? I'm going to move it 1 to the left. Okay, so now we have 1.092. Okay, now I need to think this through a little bit. Did we make that 10.92 smaller to get to 1.092 or bigger? We made it smaller, so what that means to keep it balanced is we need to make the second number a little bit bigger. So 10 to the 7th, we're going to add 1, it's going to be 10 to the 8th. Okay, so it's a balancing act here. If you make the first number smaller, the second number needs to get bigger. If you make the first number bigger, the second number needs to get smaller. So that's going to be our final answer right there. All right, got a couple more examples here. We have 7.2 times 10 to the 6th divided by 8.0 times 10 to the 9th. Again, we are going to divide like parts. So I'm going to do 7.2 over 8.0, and I'm going to do 10 to the 6th divided by 10 to the 9th. All right. So 7.2 divided by 8.0 is 0.9. Now, what am I going to do with the exponents here? I have 10 to the 6th divided by 10 to the 9th. Now, before I was teaching you to cancel out 10 to the 6th and stuff, for this, I would probably just do what you're supposed to, not what you're supposed to do. I would just go ahead and subtract the exponents, right? When we divide, we subtract. So I would probably stick with this for now. We're going to do 6 minus 9, and it's going to be 0.9 times 10 to the negative third. Okay, with scientific notation, don't cancel. You want to actually subtract the exponents. Okay, is this in scientific notation right now or no? It is not. 0.9 is not between 1 and 10, so we need to move it to make it between 1 and 10. So I'm going to move it 1 to the right, which makes it a bigger number. So what am I going to do with the second number? If I made 0.9 to get to 9 and made it bigger, the second number needs to get a little bit smaller. So I'm going to subtract the power of 10 from the negative 3 to make it negative 4. Negative 4 is smaller than negative 3. And that's going to be our answer. All right, we have 2 last examples to try on our own. Why don't you guys see how you do, and then we'll go over them in a second. Okay, we're multiplying here. We have 3.45 times 1.8. Let's multiply those first. And then we have 10 to the 5th times 10 to the 3rd. So 3.45 times 1.8 is 6.21. And then we're doing 10 to the 5th times 10 to the 3rd. We're going to add the exponents. We get 10 to the 8th. Is this in scientific notation right now or no? It is, because 6.21 is between 1 and 10. So this is going to be our final answer. All right, last example. We have 1.2 times 10 to the negative 6 divided by 4.8 times 10 to the negative 11th. Well, we're going to go ahead. We're going to divide like things here. So 1.2 divided by 4.8. And we're going to do 10 to the negative 6. Divided by 10 to the negative 11th. So 1.2 divided by 4.8 is 0.25. Now what are we going to do with the exponents here? This is going to be a little tricky. This is negative 6 minus negative 11. So we're going to do chop, chop, and make it plus 11, which equals 0.25 times 10 to the 6 plus 11 is 5. All right. And now, is 0.25 between 1 and 10? It is not. So we need to move the decimal 1 to the right to make it 2.5 times 10. And then what's our exponent going to be? Well, we made 0.25 bigger to get to 2.5, which means we need to make the 10 number smaller. So we're going to subtract the power of 10 from 5. It's going to be 10 to the 4th. And that's going to be our final answer. All right, that is all I have for you today. Thank you for watching. Have a great day, and we will talk soon.